Okay. Welcome to Trig 2015, the ancient art of trigonometry. We are with our instructor here, Mr. Kritzik, Doug Kritzik, our student, Marco, and our cameraman and instructor, James Howard. Okay, so trigonometry is all about position. Okay, very important. If somebody asks you what is a trig function of an angle, the first thing you should ask them is which angle are you talking about? Okay, all right. So let's say we're given a triangle. Okay, and when I indicate which of the angles I'm talking about, now a lot of the triangles that we'll be using will be what are known as right triangles. Do you know what a right triangle is, Marco?
Yes.
What is it?
It's a 90-degree angle.
One of the three angles is
90 degrees.
very good. Now, of these three angles, the one that's 90 degrees or a right angle is going to be this one right here. You agree with that?
Yes.
Now, normally they make a little symbol, but it's pretty obvious which is the 90-degree angle, this one right here. But sometimes they use this little symbol there to indicate, to show you that that is the angle, that is the right angle or 90-degree angle. Now, so one of the first things that you have to do is to indicate which angle you're referring to, and it won't be the right angle. So one of these two remaining angles will be the angle that we'll be referencing for this particular trig problem or trig problems in the future. We use two different Greek symbols to indicate an unknown angle. We use this Greek symbol, which is the Greek symbol. Anybody know what this one is? Show of hands. James?
Theta.
Theta. Yes, this is the Greek symbol theta. And then we use another one. We can use other ones. These are kind of like, instead of letters like A, B, and C, we're going to use these. That way you'll know we're talking about an unknown angle. All right? And then the other Greek letter that we use is this one here, which is the Greek letter. What's that one?
Phi.
Phi. Okay? So we're either going to be using theta or phi to indicate one of the angles that we'll be referring to. So I have to label one of these two angles as the angle that I'll be referring to. So I'm going to start out by labeling this angle right here as theta. That means that when I label the three sides, I'm going to be labeling in reference from their location from this angle, theta. And that's what trig is about. It's all about the location of the sides in reference to the angle that you're talking about. Okay? And now, what we do is this. When we label the angles, we also use capital letters to label angles. So let's say I didn't indicate this angle. I'm going to go back a second. Let's say I had started out by labeling the angles with just A, B, and C. Does that stick? No. I'm used to a magnetic eraser, sorry. So anyways, when we label the angles and we're not labeling one as theta or phi, and we just randomly label them, such as A, B, and C, we use capital letters are used to indicate angles. So I'm going to label this angle here as capital A, this angle here as capital B, and this is important. The angles have to be uppercase, capital letters, and the right angle has to be angle C. These two angles, either one could be A or B. I could have labeled this one A and this one B, but the right angle has to be C, and the reason for that is the side directly opposite the right angle has to be lowercase c. That's a rule. So the side directly opposite this angle, right here, will have the same letter, but lowercase. So this one will be lowercase c. And the side opposite this angle, which would be right here, has to have the same letter, but lowercase. So that would be A. And over here, the side opposite this letter here has to be what letter?
Lowercase b.
Very good. Okay, so that's just a little bit on labeling the sides. Now we have a special name for the side that is directly opposite the right angle, the lowercase c has a name. Do you know what it is?
Okay.
Okay, it is the, James, do you know this?
The hypotenuse.
Very good. So this side here, that's directly opposite the right angle, is called the hypotenuse, and you can abbreviate it as HYP, spelled hypotenuse like this. Hypotenuse, but I'm going to use HYP here to indicate that this is the hypotenuse. The hypotenuse will always be the side directly opposite the right angle. So these two right here, non-right angles, well, it'll never be opposite one of those two. Now also, the hypotenuse has one other interesting property. It will always be the longest side of the three sides. So lowercase c will always be longer than either one of the other sides, A or B. So lowercase c, the hypotenuse, will always be the longest of the three sides. Okay? Very good. Now, one thing that you should know, another property of triangles before we really get into trig more properly, is that if you add up the angles, if you add up these three angles here, the measure of each of those angles, so we would be adding up angle A plus the size, and these angles will be measured in degrees. One of them could be 40 degrees, we would label it like that. And then the other one down here might be 50 degrees, we'd label it like that. Okay? And the right angle is what measure?
90.
Yeah, so that's always going to be 90 degrees. Your right angle is always going to be a measure of 90 degrees. And if we add up the measure of these three angles, angle A plus angle B plus angle C, it will always be equal to the same number. What number, do you know?
180.
Yeah, 180 degrees. Always say your units, please. Yes, so this is automatic, and it's true. This is true with all triangles. Not just right triangles where one of the angles is a right angle, but this is true with all triangles. If you add up the sum of the three angles, it will always be equal to 180 degrees. Even if it's not a right triangle, let's just say if it's a triangle that looks like this. Okay? So if we label this A, B, and C, if we add up the measure of these three angles, since it's a triangle, it will always add up to 180 degrees. Even if there's no right angle, even if there's no right angle in the triangle, the measure of the three angles will always be, the sum will always be 180 degrees, okay? But for our purposes, just starting out, we will be using right triangles, okay? We will get to these triangles where none of the angles is a right angle in a couple of weeks when we do the law of sines and the law of cosines. Then we'll get into solving for the sides and the lengths, the length of the sides and the measure of the angles. We'll find them when none of the angles are 90 degrees. That's coming up. Okay, that'll come later. All right. So that's just a little background on okay. When I go like that, that means